So I'm going to take some time to run through the things to think about as you're studying for the final. Remember, you can make a one-page front and back cheat sheet. So be creative in writing down notes. I will provide a periodic table. I will also provide the little sheet with the sp2 and sp3 hybridizations and the geometry names and so on. All right, so number one, which type of radiation might travel in a straight line when passed through an electric field? So if you're passing through an electric field in a straight line like this, you want something that would not be affected as it passes through a charged area. So alpha particles have a positive charge on them because they're a nucleus. A beta particle has an electron which is negatively charged. X-rays have no charge. Protons are positive. So which one of those four things would not be affected by an electric field? That would be the X-rays, because it's light, and light doesn't have a charge. All right, when an atom gains an electron, it's going to become negative because electrons are negative, and it gains a little bit of mass. Remember, when our mass and charge, so if we're looking at mass and charge like this, and we have protons, neutrons, and electrons, protons and neutrons have a mass of 1. We said that the electron has mass of 0, but it has a little mass, just not enough to compare to the overwhelmingly large mass, so to speak, of the protons and neutrons. The electron's about 2,000 times less massive than the proton or a neutron. And in terms of charge, protons are positive, neutrons are 0 charge, and electrons are negative. So if you add an electron, you're going to become negative and add a small amount of mass. So negatively charged and gains a small amount of mass. Number 3, pairs of atoms held together by ionic bonds, and ionic bonds form between metals and nonmetals. So you're looking for the metal-nonmetal combination. So H is a hydrogen. Hydrogen is a nonmetal. It is on the metal side of the periodic table, but it physically is a nonmetal, and everything else on the left side of the periodic table is metallic. So just to review, on the left side of the table, left side of this line here, everything over here is metal except for hydrogen. And nonmetals are on that side. All right, so nonmetal, nonmetal, that's not ionic. Nonmetal, nonmetal, that's not ionic. Metal, nonmetal, that's your answer C, because of metal, nonmetal. All right, when sodium is dissolved in water, so you got to think about sodium would be positive, and chloride ions are negative. Think about a water molecule. Since this is a polar bond between the H and the O, the electrons move toward the more electronegative element like that. That makes this end of the water molecule negative and this end positive. So which of these two ions would be attracted to the negative end? Right there. So the sodium ions are attracted to the oxygen atoms of the water molecules. That's B. Okay, asymmetrical and is polar. You draw the dot diagrams for these. So N2 looks like this. Cl2 looks like this. H2O looks like this. Because of these unshared pairs of electrons, it's bent, and therefore it is 2 H's down here, nothing up here, so it's asymmetrical. And then the carbon tetrachloride, the CCl4, looks like this. Or that's that tetrahedral configuration. So the one that's asymmetrical and is polar is water. Okay, forces between atoms that create chemical bonds. What kinds of subatomic particles attract each other? Nuclei don't attract each other because that's positive and positive. Electrons don't attract each other, negative and negative. Protons and nuclei are positive and positive because the charge on the nucleus is positive. So the only thing this could be would be protons and electrons. Number 7, metalloids are the elements here in this gray area. If you look at the key, it'll actually tell you that they're metalloids right here. And they have properties of both metals and nonmetals. It's interesting because as the atoms get larger, they change from nonmetals to metals in a family. Say nonmetal to metal, carbon and lead are in the same family. And that has to do with the size of the atoms. As metals tend to lose electrons, and as the atoms get bigger, it becomes easier for them to lose electrons. So you gradually change from nonmetal to metal. So arsenic is a metalloid, because it has both metallic and non-metallic properties. And one empty spot in their valence shell, number 8, that would be 1 in the outer shell, 2 in the outer shell, 3, 4, 5, 6, 7, and 8, except for helium, which helium only has 2, but the rest of them have 8. So which one has one empty spot? This family, and that family is called the halogens. The smallest radius. Okay, the smallest radius atom, you'd have sodium, magnesium, potassium, calcium. Sodium, I'm going to put protons and electrons on a chart, and I'll put the Na plus and Mg plus 2. We'll just compare real quick. K plus 2, Ca plus 2. All right, so sodium has 11 protons and 10 electrons because it's lost 1. Magnesium 12 and 10 because it's lost 2. K 19 and 18, 20 and 18 for calcium. All right, so looking on the periodic table, you'll notice that sodium and potassium, magnesium, and calcium are on different rows. So since sodium now has 10 electrons, here's where they are. You've got a ring, there's a nucleus and then a ring around it with 2 electrons and another ring with 8. Magnesium would be the same thing, 2 in this ring and 8 out around it. Okay, I didn't draw that to scale. So really magnesium is going to be smaller. We'll call this one magnesium and they'll call that sodium. All right, so then potassium would have 3 rings, so nucleus, ring 1, ring 2, and ring 3. So it has to get bigger because it's got an extra ring. All right, so then we're comparing magnesium and sodium because calcium and potassium have this extra energy level, so they're going to be bigger, not smaller. So now we compare magnesium and sodium. Magnesium has 12 protons pulling on 10 electrons. Sodium only has 11 protons pulling on 10 electrons. So this will be your smallest atom because you've got more positives pulling on the same amount of negatives. So the answer is B. All right, aqueous solution of XCl2 contains colored ions. Colored ions are usually found in the transition metals. Transition metals are the D sublevel block right here. So the only one of these that's in that D sublevel block is copper. Okay, common in metals. Metals they tend to lose their electrons easily because they're bigger. Remember, size is getting smaller as you go up here. So size, as you go that way, gets smaller. So the bigger ones are down here. Bigger elements then lose electrons easier. So they have a low ionization energy, so it's either A or B. And electronegativity is attraction for electrons, so big atoms don't attract electrons as well as small atoms. So the bigger atoms have a lower electronegativity, so they have a low ionization energy and a low electronegativity, and the answer is A. When charges change during a chemical reaction, the particle that changes to make ions is the electrons, so that's A. Okay, so for this compound, you know that sodium, Na2SO3 is like that. So we said sodium is plus 1, oxygen's minus 2, and the whole thing has to equal 0. So 1 times 2 is 2. Negative 2 times 3 is negative 6. So 2 plus x plus negative 6 equals 0. Or 2 plus negative 6 is negative 4 plus x equals 0. So what's x? X is 4. So the oxidation state of sulfur is positive 4. In chemistry, reduction means lowering charge by gaining electrons. So a reduction half reaction would always involve the gain of electrons, and the charge would go down. So that's a decrease in the oxidation number. That'd be A. In general, which property do molecular compounds share? All right. Remember that molecules and molecular compounds are weakly attracted to each other. So if they're not hanging on to each other very tightly, then it's going to be easy to melt them and easy to separate them. And since boiling and melting are separation kind of concepts, where if you boil something, you'd separate the molecules as you move from liquid to gas. If you melt something, you separate things as you go from solid to liquid. So separating molecules, low boiling points, would be characteristic of molecular compounds, because molecules don't attract each other very much. The attractions between molecules are all weak. Okay, which of the following noble gases have the highest boiling point? If you remember, I showed you a little video a couple days ago. I had these spheres on it. They were all gold spheres, and the electrons are sloshing around, and the kind of the spheres became lopsided, kind of like that. And that's because the electrons are sloshing, and while the electrons slosh around, they create this temporary dipole. It just lasts for a fraction of a second, then goes back like it was. But during the time that it's lopsided, it's polar. That end's negative, and that end's positive. All right. Now, if you have more electrons to move around, it takes longer to go here and then get back to normal. So the bigger the atom is, the stronger the London dispersion forces are, the stronger the attractions are. So you want to pick the biggest one of these, and that would be xenon, because xenon is the furthest one down the chart. All right, the smallest atom, remember we talked about this size thing a minute ago. As you go that way, things get smaller. So as you go to the right, they get smaller. As you go to the top, they get smaller. So lithium, boron, carbon, and fluorine are all in the same series. There you go, lithium, boron, carbon, fluorine, all in the same row. So the smallest one's going to be to the right. So the answer is fluorine. And as an electron moves from a 3s to a 4s, that's 4s is higher energy than 3s, so the energy has to increase. Okay, energy put in, endothermic. So if you're going solid to liquid, the molecules are going to have to speed up to get to the liquid. So that is endothermic. If you go from solid to gas, like dry ice, it sublimes. The molecules got to speed up. That's endothermic. Liquid to solid, the molecules are going to slow down. So that's exothermic, because they're slowing down and releasing energy. Liquid to gas, that's going to require energy because you're making the molecules separate. So that's endo. So the answer would be E, more than one of those. All right, when two oxygen atoms combine to form a molecule of oxygen, oxygen always occurs like this. It wouldn't do that if it wasn't more favorable to do that. In the universe, things tend to go toward the lowest energy state. They want to get toward increased stability, lower energy. So we know that energy is going to be released. It's either that one or that one. And energy is always released when bonds are formed, never released when bonds are broken. So energy is released when bonds are formed, and the answer would be D on that one. Third energy level of nickel. So if you write the electron configuration for nickel, nickel has a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 8. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 8. So 8 and 6 is 14, and 2 is 16. And the nuclear charge of a lead atom. Lead is number 82 on the periodic table. 82. So that means it's positive 82. That's what the charge of the nucleus would be. All right. The highest first ionization energy, would that be a big atom or a small atom? So if it takes a lot of energy to get an electron away from an atom, it's going to be a small atom. So this atom is lithium. This atom is beryllium. This atom is sodium. This atom is magnesium. You can tell that by just adding up the electrons. 11 electrons, 12 electrons, and so you 11, 12, 3, 4. So which one is going to have the highest ionization energy? Well, as atoms get smaller, ionization energy increases. So as you go to the right, ionization energy increases. As you go up, ionization energy increases. If you're comparing these four elements, the one furthest to the right and furthest up is beryllium. So the answer is B. Which type of bond is formed when an atom of chlorine shares electrons unevenly? Uneven. But they're sharing electrons. So sharing electrons means covalent. Unevenly means polar covalent. There's going to be a positive end and a negative end. So polar covalent. And if you're doing a simplest ratio of nitrogen to oxygen in the compound nitrogen 4 oxide, here's nitrogen, it's going to have a +4, it's going to give away 4 electrons. You have oxygen. Oxygen has 6 valence electrons. So if I have a nitrogen with 4 to be given away, that's kind of weird for nitrogen. All right, so this guy is going to go here, and this guy is going to go here. I still got 2 of the 4 I'm going to give away, and those 2 are going to go into another oxygen. Whoops, I mislabeled that one. Just there you go. So there and there. All right, so that's nitrogen dioxide. Now this particular compound is chemically very unstable because you got this other electron hanging out there. So it's a very unstable compound, and consequently it's chemically very, very reactive, and it's poisonous gas is what it really is. Anyway, so the ratio, the simplest one is going to be one of these, 2 of those, so it's NO2, so it's 1:2 ratio, A. 26. Diamonds are network covalent. In network covalent, you have an atom bonded to an atom, 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 and another atom, and an atom like that, an atom like that, like that, like that. You notice that there's not any break ever, they just keep connecting. So network covalents are very, very hard. Like, diamond is the 10 on the hardest scale. It's the hardest thing we know about. So what happens is the diamond then doesn't have any discrete particles. It's just all one big molecule, sometimes called a macromolecule. It certainly doesn't crush easily, and it can't conduct electricity, and it has a super high melting point because these bonds are very strong. Right. Now H2O compared to H2S has a special kind of bonding. I showed you a little video about this. What day was that? It was last week. We did a little overview of the bonding types. It's still on the website. If you go to that Oklahoma State link, it'll show you hydrogen bonding. But hydrogen bonding exists between atoms, or between molecules, when inside the molecule you have hydrogen bonded to a highly electronegative element like oxygen. So the hydrogen bond would be right here. It's not really a connection, but since that end is positive and that end is negative, they attract each other. That's called a hydrogen bond. Sulfur would look like this. It looks kind of very similar. Like that. But the hydrogen bond between these two can't exist because sulfur is not as electronegative as oxygen. Consequently, the sulfur can't pull the electrons up as far, and it doesn't get as negative. And since it's not as negative relative to the positive over here, then the molecule won't attract another molecule very well. So that's why this molecule, this stuff exists as a gas, because the attractions are not very strong between the molecules, but water, of course, exists as a liquid because the attractions between the molecules are strong enough to make the molecules stick together. So the answer to that one was hydrogen bonds. Okay, 28, an element with 5 electrons in the p sublevel in the ground state. Here's the p sublevel, right here, remember this block. 1, 2, 3, 4, 5 in the p sublevel. Remember, that's 7 total in the outer shell, but an element with 7 in the outer shell would have 5 in its p sublevel of the outer shell. The outer shell consists of the S2 and the P6. So if there's 5 in the outer shell, it's an S2, P5, and that would be this family. That's the halogen family. In period 3, period 3 means each successive element has a larger radius. That would mean as you're going across this way, the radii are getting bigger. That would be wrong. Since we know that the radius is getting smaller as you go this way, we know the electronegativity is increasing because electronegativity means attraction for electrons. The atoms get smaller, they attract electrons more. So we know that this answer is wrong, and that answer is wrong, and so is that one. We know similar properties are for the elements that are in the same families, not going left to right. So that answer's not right. They have valence electrons in the same principal energy level. Now, the first time when I read this, when I was making the key for this, I thought, oh, that means they have the same valence electrons. But it doesn't say that. It says the same valence electrons. They have valence electrons in the same energy level. So if you did the electron configuration for lithium, it'd be 1s2, 2s1. For beryllium, it'd be 1s2, 2s2. For boron, it'd be 1s2, 2s2, 2p1. Notice that all the valence electrons are in the second energy level. So the answer is D, they're in the same energy level. Okay, active metals would be the ones that are metals lose electrons when they react. This is a little video I showed you with the little glass dish exploding. So of these elements, you'd pick the biggest one because the bigger ones lose electrons easier. So it'd be K, because K is the one furthest to the left and the furthest down of these elements. So here's Br way over here, so K is way over here, so K is more active. Gallium is here, K is still further left. Germanium is here, K is still further left. So the one furthest left and furthest down would be the most active for metals. It's interesting that for nonmetals, the most active is the smallest one, whereas for metals, the most active is the biggest one. Okay, and when I say smallest one, that means excluding the noble gases. The reason the noble gases are not active is that they do not have any open spots in their outer shell. Okay, which of these elements has the most metallic properties? It'd be the biggest one, because those are the ones that lose electrons easiest, so I think that's going to be, of these elements, is bismuth. That's A, the one furthest down. Most metals in the solid phase, metals are not brittle. So you probably know that from your everyday experience. Metals have remember we talked about them briefly, they have delocalized electrons, so the electrons just kind of act like a big jelly holding together the metal ions. And the electrons can move, and that makes the metals able to conduct electricity real easily, makes them malleable and ductile, and so on. All right, which one is classified as electrolyte? Electrons exist as ions in solution and originate from soluble ionic compounds. Ionic compounds, we said earlier, were metal, non-metal, so the only one here is that one. So you don't have to worry about whether it's soluble or not if you just recognize that it's ionic. Okay, which one of these has the highest electron affinity? Would that be a big atom or a small atom? So it'd be small atoms, because small atoms attract electrons more. Smaller on this side, so we're looking at F. But then you have to decide if it's F2 or F minus. So F2 would look like this. F minus would look like this. Which one looks more likely to have an open spot? Well, this one has 8. It's got the 8th one because it's a -1 charge. So if this bond was broken, then I would have this. So there'd be an open spot on each atom. So the reason fluorine pairs up to be diatomic is to try and share an electron to fill this empty spot. But if there's another option, it would rather do the other option. So if there's some other element that could give an electron to it, it'll break apart and take that electron and just pull it right in. It's a very high electron affinity. So the answer there is A, fluorine, very strong oxidizing agent because it's a small atom and it has an open spot in its outer shell. Okay, between the hydrogen atom and the oxygen atom in CH3OH, that looks like this. So we're talking about this bond right here. So that's O and H. They're both nonmetals, so they make covalent bonds. So it would be a covalent bond, and the question is, will it be polar or nonpolar? Well, oxygen is more electronegative than hydrogen, so that means the electrons are going to move toward the oxygen. So it's going to be a polar or covalent bond. Okay, we'll go to the bottom of this page, and I'll stop and start a new video so this one doesn't get so long. All right, so number 36, a student determined the solubility of an unknown solvent in various solvents. So you have this solid, you put in benzene, it doesn't dissolve. Benzene's nonpolar. Put in water, it's soluble, dissolves. Ethanol, it dissolves a little bit. Toluene, not going to dissolve. And toluene's nonpolar. So it dissolves in polar things, but not in nonpolar things. So which one of these would be more likely to dissolve? An ionic thing like salt, a nonpolar thing like oil, a network thing is like diamond, they don't dissolve in anything, and metals don't dissolve either. So you're really between ionic and nonpolar, and since it dissolved into water, and the water is polar, remember it's negative here and positive here. Ionic things have charges, so you got NAs and CLs and CLs and NA like that, where you have positive, negative. So this negative end would attract the positive ions, so I just draw it like that. Another CL out here. So this negative end would attract that and cause it to dissolve. So the unknown solid is probably ionic. It may not be sodium chloride, but it'll be ionic. All right, and then electron affinity is the energy change when you add an electron to an atom. So which one of these would be adding an electron to an atom of sodium? It would be either this one or this one. And if you add an electron, does the charge become positive or negative? Negative, so the answer is C. All right, I'll stop there and save that. We'll continue on in a moment on the next video.